There's all kinds of stuff going on. Yeah, oh, I better turn off the microphone.
You're gonna be able to make,
Hello.
Nobody wants to hear this
PJs
right
today?
now.
I am.
Good. I've got a series of things I want to talk about. We can wait till then.
Sounds good. Okay, looking forward to it. Well, thank you all for coming to the September North Houston Space Society meeting. And anyway, I thought I'd start off by showing you some of the pictures of some of the things that we've done. You know, we went on the tour of NanoRacks and saw the Bishop airlock before it went on the space station. We went to the Infinite. We also did like the Comicpalooza event. And I should say I'm Nathan, just in case y'all don't know. And today I had just a few little opening remarks I thought I'd share with you. And then Patricia is going to give us the latest highlights on space weather, which is something that's going to be a big, more of a concern as we branch out into the rest of the solar system, the activity of the sun and its effect on vehicles that are going from the Earth to the Moon or Earth to Mars. And then Greg Stanley is going to give us an update on the latest space news. Of course, every month he has to really struggle to be selective on what to do because there is so much happening in space. And I mean, just between now and the last meeting, just thinking about the last week could take up probably hours and hours discussing. And then we're going to have Chris talk about the rise of the rocket. And then we'll try to end about 4 o'clock here. And afterwards, those of y'all that haven't got enough of hanging out and talking about space are welcome to join us over at PJ's. And to kind of encourage y'all, I got 5 PJ's gift cards that we'll have a drawing for, along with some other things at the end of the meeting. I guess, first off, how many of y'all have heard of the author Isaac Asimov? Okay, pretty much everybody. iRobot is, of course, one of his famous things in the Foundation series. How many of y'all think that Isaac Asimov knows who the first 2 people that landed on the moon were? I mean, I would expect he would, being a prominent science author. So he would be. So I was reading this book, Lucky Star and the Moons of Jupiter, by Isaac Asimov, and they're going from one of the moons of Jupiter to another, and one of the characters is talking about what a historic event this was. He says, think of all the trillions of people in the galaxy. Think of how few of them have had the luck to be the first on the world. You could almost name them all off. And then it says, Johnsky and Sterling were the first men on the moon. And I was like, wow, what are the odds of that? And we have some feedback.
Do you know when that was published?
That's the key thing. That is the clincher.
I mean, I talked to Asimov in 1960 and 1970. So I'm familiar with his writings and his work.
Yeah, this was published, copyrighted in 1957. So he didn't have the benefit of actually knowing what the history would be. So I thought that was kind of, it threw me for a loop there. Well, this one is Lucky Star and the Moons of Jupiter. It's part of a series of books that he wrote. But it's... Yes, exactly. Yeah. And he actually wrote it under a pen name, Paul French, which I thought was interesting. But anyway, with that, let's move over to space weather. And let me get your slides up real quick. Oh, no trouble. And here, I could give you this too.
Oh, there it is.
Okay, cool. And there you go.
Yay. Okay. Hi. With the exception of the past week, this past month, space weather has been relatively quiet. We've had a few X flares, good number of M flares, but nothing out of the ordinary for near the peak of solar cycle 25. But this morning, we had an X 4.54, which is actually the 5th biggest solar flare of solar cycle 25. It, from imaging, it actually looks like a filament may have erupted. This is not going to be Earth directed. We might get a little bit of a glancing blow, but other than that, other than some good aurora, maybe, it's not going to impact Earth. As the next few days come around, this solar flare, this sunspot will come into the Earth directed region. And so I actually brought up the magnetic imaging so we can look at it. And you can actually see these two images are of the sunspot this morning before the solar flare and of the sunspot after the solar flare. This was at noon, our time. As you can see, there's little to no degradation in any of the diversity of the polarity. When you see the red and the blue, those are opposite polarities. So that means some of this stuff is still hard for me to explain. Basically, the more mixed up the polarities are, the more they're interfering with each other, the more activity we're going to get out of it. And so as you can see, it is very, very chaotic.
With those two polarities, aren't you suggesting that the magnetic flux is coming out of the positive end going into the negative? So isn't that the bottom of the loop? As the flare comes out, it comes out of one zone and goes back into the other. Isn't that what you're showing in the map?
It can do that, but it does not always do that.
So you're saying that you can manage the positive and negative polarity zones without there being an eruption upward and downward?
I'm not saying we can manage anything.
Well, whatever freedom this is all in a single plane.
Yeah.
And we're not talking, you've got to figure that the flare is actually leaving the sphere and coming back.
Yes. Yeah. You can actually see it here.
Yeah, that's exactly what I was referring to.
And this actually did launch off of the sun. It doesn't always, like you were saying, sometimes it does go back in, but in this case, it did launch off.
What's that filament composed of?
Plasma.
Is this picture done by the satellite we've got up there?
Yes. And this is the HMI magnetic imager. It's what we use to classify the sunspots, because with this imaging, you can actually see more of the polarity and you can see the contrast a lot better than when it's just a bunch of squiggly lines. And I actually was going to do a forecast talking about sunspot 3825 and how it's very likely to give us a solar flare, and that was actually most of my presentation. How the sunspot is very active, very dynamic, and before I got here, it did it. And so I was going to go over I think it's cinescopic map. And with this, you can actually see, you can see 3825 right here, and you can see that there's probably something right here coming in. And I don't know if y'all are familiar with high and low pressure systems in Earth weather, and how on those boundaries is where we get storms forming. Well, it's kind of the same way up there. So these are neutral lines. And if you can see, when those neutral lines form little outlets, just kind of like with low and high pressure, then that's where the activity starts up. And Sunspot 3825 is very likely to give us a lot more activity coming up. It's been kind of slow. We've had, like I said, a good number of X flares on the far side. It's possible that 3825 was actually the one giving us the flares on the far side. We actually did also get some up to the S1 radiation level. So we had several proton events that actually impacted us from the far side.
On the far side,
Yes.
that's really, that kind of strange. Shouldn't they be heading away from us? Are you heading away?
Yes.
What makes it come back around towards us?
Okay.
The heavy intense magnetic field?
When a far side eruption comes out, there's usually sympathetic eruptions. So some material does come from other parts of the sun. Also, when a solar flare is large enough, when it puts out enough material, let me see how, let's say this hole right here shot out a cloud of steam. When that cloud of steam comes out, some of it's going to go back up.
Oh, it's going to recirculate.
Yes. And there's also the Earth is spinning and the sun is spinning. And the solar wind is going to bring some of that around to us as the solar wind comes around.
Yeah, the protons are positively charged. There's going to be an interaction between the electric field of the sun and the magnetic field of the sun, and it's going to do strange and wonderful things to the particles shooting out of the sun, forming whirls and loops, gosh knows what else. Okay.
And since the sun has an atmosphere form, you're getting the same effect as a vortex. So when something shoots up, you get a curve, this one comes back around.
Yeah.
But it's the same as a vortex.
And just to give y'all a brief overview of this, so y'all can look it up on the Space Weather website, the NOAA Space Weather website. These make it actually really easy to read because you can see all the boundary lines really clearly. These right here are cornea holes. And those actually do produce a lot of solar wind that can also give us aurora. And with that, I wanted to give y'all some of the aurora that we've had over the past few days from, it was an X1 something the other day that gave us a little bit of color.
You had to be farther north to be able to see this?
Most of the time, yes. It can come down here. A few months ago, I showed a picture of the May 10th event where I got a picture just north of here at the Texas Renaissance Festival. Pictures were as far south as Mexico, northern Mexico. They got aurora. I've shown the slides in I've shown some of my pictures in previous slides, but if you want to come see me after, I can definitely show you more the pictures that I got.
What is aurora?
Aurora is the energy interacting with our atmosphere. I forgot if it's the electrons or protons. I can't remember at the moment.
It's the ionization energy interacting with the nitrogen, oxygen, molecules in the atmosphere that
Yes.
each one of the atomic structures uses a different color energy when it interacts with a high energy beam coming in. The colors of the aurora are basically related to which gases are being activated, and in some cases at what elevation. It depends, because depending on the elevation of the nitrogen molecule or the oxygen molecule, etc., determines what its molecular structure might be, therefore what electron shell we use. Yeah, the energy is coming off the sun.
Aurora is pretty much only seen at night. I've heard of people saying they see it during the day, but I've never like seen pictures of it shown during the day. And yeah, these are low level. When I got the pictures here, it was mostly just air glow. I mostly got red. I did get some of the bands that were red, and that's higher levels of the atmosphere.
It can be a very sort of static show, just sort of hanging there like that,
Mhm.
sort of fluid cloud, or it can go to the other end of it.
Yeah.
And it can be very dynamic.
You can see things in aurora more than you can see things in clouds. It lots of forms.
The detail is amazing. Just very briefly, I was friends up north in Ohio. I walked into my backyard one night and I looked up and I had a near religious experience because I saw a giant hand covering most of the sky. I could very plainly see a thumb and 4 fingers, and they were moving. And then after about 3 seconds, I gathered my thoughts and realized I was looking at an aurora. It was a really amazing experience.
Oh, yeah.
And it was, you could see the ripple. It would start over on the left sky, and then in like 2 seconds, it dropped me all the way over to the far horizon. It was, whatever it was moving fast. And it just made that hand move, a giant hand in the sky. Very impressive.
It definitely is. I feel like it was a religious experience getting to even see what I saw here, which was glow, basically. But it's absolutely beautiful if you get the chance to see it.
I got this. Here, double check. Yeah, I actually went up to Alaska in this February, figuring in the middle of Alaska, 30 degrees below at night, and to see aurora. And it turns out my son sitting in Seattle on his back porch during these recent big ones got better pictures than I did. So, but they're still impressive. I mean, the pictures actually make them look better than they are because they can capture the light over a longer period of time because of time exposure. So they usually aren't quite as bright as that, but in the really good ones, they can be. All right, let me get started here.
You want to do?
Okay, so this monthly news, I will see covering basically since the last meeting, and you can kind of get an idea from the pictures here where we're going to be, what we'll be talking about. But we got to start off with this. I mean, the good news, there's a record number of people were in orbit this last week or so, 19 people. That is actually a record. And that's actually in orbit, meaning achieving orbital speed, not actually just up for 10 minutes. I mean, these people are all there. Now, that did count 12 people for the space station. During that period, the Russians launched a Soyuz craft up there with 3 astronauts, 1 American, 2 probably Russian. But once they crossed the von Karman line at 60-some miles, they started counting too, because they were already going to be in orbit approaching the space station. And then, of course, they actually got there. So they had 12. Chinese space station has their contingent of 3. And then there's the Polaris Dawn mission, which was really a standalone launch going up quite a bit higher than the space station, actually. And we'll talk about that next. So this was a privately funded mission done on SpaceX, 4 astronauts going to Crew Dragon, launched by a Falcon 9. This was launched on September 10th. And as far as I know, they haven't come back yet. They're probably due either today or tomorrow. I'm not sure exactly when. But they went up 1,400 kilometers, which is quite a bit higher than the space station. That's actually a record since the Apollo, other than the Apollo moon missions. That pretty much is the highest anybody has gone. Well, let's see, it's 1.6 is the conversion. So, well, multiply by about 1,800. I think it was 800 or 900 miles, something like that. So, now they usually when you go up on these craft, you would automatically think, oh, they're going to the space station. Actually, they didn't go to the space station because they were just zooming much higher than that. The one thing in particular that meant was they got a lot more radiation when they're up at that highest altitude. You're in the Van Allen radiation belt. And they probably, I think they got something like maybe 6 orbits for that. They didn't continue after that, but they did want to collect some data. There's still a lot of concern about how much time astronauts can really spend in the higher radiation environments. And so they came back down around 700, 750 kilometers. So anyway, they then did the spacewalk. And you can see that in this picture here, that's just an illustration, but it gives you the idea that what they really were doing was opening up the hatch. The entire capsule then is under vacuum. So there's no airlock on this thing. This is basically just the Dragon capsule they normally go to the space station with. So although only 2 of them officially did a spacewalk, it was really more a space glancing, glance, where they didn't come out any farther than that. But anyway, all 4 of them in effect were subjected to the same conditions. They had to be because there's no airlock, so the whole thing is at vacuum. And this is sort of the money shot. This is the one that everybody, you'll see this one everywhere. It's probably going to be an iconic picture, for the rest of the year. And mostly what they were doing is really testing out the new spacesuits. So these are new spacesuits. And so what they were doing was, they're raising the arm, they were rotating and trying to see what kind of limits would be imposed, because like I said, it is a new spacesuit. Now it is based on the ones they're using to go to the ISS, but it had to be beefed up quite a bit, to handle the more temperature extremes and so on.
So why did SpaceX decide with traditional supplier, which are ILC? Any comments about that?
Well, yeah, basically their attitude is, they have several parts of their philosophy, and you're all familiar with a lot of the philosophy, like minimize number of parts and reuse everything. There's another part, which is mass production. And that's been a key to everything they do as well. What they want to get to is having spacesuits that can be mass produced. Someday we're going to need 1,000. Someday we're going to need 10,000. We can't build them as individual spacecrafts that cost $500 million each. I mean, they got to start somewhere. Now, they didn't do the same kind of suits that you have at the space station. These are not self-contained. They're still tethered. There's oxygen and all kinds of. There's an umbilical they're connected to them. Actually, the next picture shows that. You can see it there in this is the view from inside the capsule as they were just opening it up. In fact, what's interesting is that's just a hand crank. It looked like, when they're about to go up, they just rotated the crank and opened up the hatch. But you can see that umbilical tether there. So that's handling all life support. They didn't really have a self-contained system. That would come at some point, but they didn't feel that was necessary. And you can imagine they're going to iterate on this. They're not going to do one set of spacesuits, back in the 1970s or something like they're still using it at the space station. They will iterate, and no doubt at some point they're going to have self-contained life support, which right now that's a separate backpack, which is attached to the spacesuits on the space station. But anyway, so they stand up there, so they're doing a lot of move around, and pretty much what they were guinea pigs. They were testing out the new suits. This is really, you could say it's space tourism, but it really was quite a bit more than that. But let me finish up on statistics here. So they were outside a total of about 20 minutes. 4 astronauts, 2 of them did this, so they went up and they moved around and everything. Total process about 1 3/4 hours. They counted from the time when they had to have the spacesuits fully functioning, turned on with life support, until they were all closed back up. And then the total, but they're actually only outside about 20 minutes. They held the rails, they were tethered. And again, that's what it looked like inside. So what I was saying, though, is it's not really just space tourism as such. One, they were being guinea pigs for a new round of spacesuits. And as I was saying a minute ago, their goal is really to make things that are mass producible. And they didn't really consider anything we have now mass producible. Basically, everything the space program has ever done, for the most part, has been pretty much kind of a one-off. And that's why it's been so expensive. And they're trying to change that in every way possible. That's everything from rockets to spacesuits. They were doing some other tests. They were testing out communications with the Starlink communication system via lasers. And so they made that work. They did a variety of scientific experiments. There's still a lot of things that are not known. For instance, there's problems with your eyes when you're exposed to, essentially no gravity for long periods of time, or even not that long a period of time. They had various experiments on that kind of stuff. So the way to look at it is they're trying to solve problems so that people can actually go to space and stay there for long periods of time. And NASA has been doing that, but they think there's still a lot to go. There's still a lot we don't really know how to do well. So they're doing that. The other thing is they're not really tourists in a normal sense. I mean, the guy who paid for it, actually, he's had quite a bit of training, and he's done, a previous one of these kind of things. Two of the people were SpaceX employees. One of them is the one who's training astronauts. So these are people who are professionally involved in the space program as it is. And the other guy was an ex-Air Force pilot who's done all kinds of other things too. Of course, the other thing to think about is they were taking all the risks, actually maybe more risks than most astronauts, because of the fact that they're going all or nothing on these spacesuits. There is no airlock. It's not easy to recover if something goes wrong. And also, it was a charitable event. They raised some money for St. Jude's. Yes?
The spacewalk, just real quick, when they did the spacewalk, was that, you said they went higher than the International Space Station and they came back down.
Yeah.
Did they do the spacewalk at the higher altitude or did they come back down?
No, it was down lower.
Okay.
Yeah, well, and the reason was exposure to radiation. They didn't want to have that much exposure anymore, so they came back down. But they wanted to get some data, that they were going to be passing through this with people, and they wanted to have, because there isn't actually that much data on that involving people. We've had obviously a lot of spacecraft have gone through those, but only people who went to the moon, pretty much the only people who have ever done it otherwise. And those people are mostly not alive anymore, so.
Down to about 490 miles. They were right on the edge of the high radiation zone. It's as close as you can get to the edge of the cliff without going over. So that's what they were measuring.
Yeah.
That's where they were existing, doing those spacewalks. They weren't in the very worst place, but they were right next to it.
Where's
Yeah.
the space station?
The space station is considerably lower than that. They're at 250 miles. And the inner edge of the radiation belt it starts at 500 miles and goes up to like 1,300 miles, I think.
Yeah, I think of the space station as like here to Austin or something. It's just really not that far when you get down to it. But it's in a pretty safe place. You're pretty well shielded from radiation.
You referred to it, but they're working on this suit because they expect to use it both on the moon and Mars. In other words, this suit is going to be used for not only extravehicular, but they want to make sure the suit can be used for Mars activity as well as the moon activity, but obviously the moon first.
Yeah. Well, even first, if there's some kind of a problem where they have to go out and do work outside of a craft, they'll have to go with a longer tether than they have. That one they have is really not long enough. But again, it's baby steps. You have to start somewhere. So, I think that's their first thing is just in case they really need to do it, they want to make sure that, without spending billions of dollars on a spacesuit, they have something that can work. Okay. Next topic, Boeing Starliner. This has been a long-running saga where we talk about it every month, and finally, it's almost over. Remember, this is the way, an alternate way to get to the space station. A craft built by Boeing. It had thruster problems and helium leaks. Ultimately, NASA decided it was too risky to send the astronauts back on it. They got up there, but there were enough problems. They were worried about it. They didn't want to have another disaster on their hands. So what they're doing instead is the people that are up there, the two astronauts that had just gone up on the Starliner, they're going back in February. And that was being discussed as the most likely outcome at the last meeting. And that indeed is what they did. So in the meantime, they got the software all fixed up and they did the landing. So an automated landing, nobody was in it, but it came back. So there's some pictures there starting at the space station on the right-hand side there. That's what the Starliner looks like when the hatch is open. They do they land on New Mexico, the White Sands area. So they use parachutes and they come down and the final resting place is right there. They have done this before. They had a successful test, a couple of years ago where they did the same thing. And so they've got the landing down pretty well. They did apparently have one thruster problem along the way, but it wasn't that serious. So, had they put the astronauts in there, it would have been okay. But nobody wanted to take that chance. So anyway, the good news is that that's pretty much over. The big remaining question is going to be, will people want to continue with Starliner? And for that matter, will Boeing want to? Because they've lost a lot of money on this at this point. They're not used to doing these fixed price kind of contracts, and they lost like $1.5 billion or something.
My observation on this is that they were contracted to do 6 missions, but they've only got until 2030 to do the 6 missions. So they may not have enough time to do all 6 missions. That's number one. Number two, they had to deal with the two. Boeing didn't have to deal with NASA's problem. We've lost 2 different shuttles. Okay, So if they'd have brought those two down and something would have happened, it would have been a terrible political accident for NASA. So NASA basically overrode them and said, no, we're going to bring them back the other way. But they went through everything they went through on the Challenger, everything they went through on the second one came down. They looked at all the details and they decided against Boeing's decision to bring them back. But it was heavily related to the fact they couldn't afford the political impact of a mistake.
Yeah.
And it was based upon everything they experienced with the two shuttle accidents.
Yeah, I mean, you know, it kind of, NASA's kind of forced into it. They basically, politically for them, it's just impossible. If somebody dies, the whole program gets set, every program gets set back, and they're not willing to do that. And that's why a lot of progress on things like spacecraft tends to get done with unmanned missions. You know, like how did all the Falcon 9 and now Starship get started? They start off being unmanned, so you can iterate rapidly, you can make mistakes, things can blow up, and nobody really gets hurt. It doesn't matter that much. You know, if you only build things for manned use, then it says right there, you're not going to do them very often. You're going to have to be really, really careful, and progress is just way too slow. Okay, next step, speaking of these kind of things, Starship. Flight Test 5, it should have happened by now. They claim that, SpaceX claimed that they were ready in early August. Now, some people have raised doubts about that, but probably they could have been. But in the meantime, since things have been delayed, of course, they've continued working and, you know, doing all the different kind of improvements they do. But everybody got thrown by a loop. The FAA is actually delaying the Starship next test until November 26th at the earliest. So that was actually quite a delay. And SpaceX has really complained about this rather bitterly, saying the delays that are being introduced are actually not because of the things you might expect. Now, the thing is, they're going to be doing a catch. They're going to actually, that's an early animation of a booster coming back to land at the, you know, the launch site. Actually, that's a more realistic one there. Still doing illustrations since it hasn't happened yet, but that's what it's going to look like. This was a little earlier version. But they're complaining, they're saying, you know, the biggest risk here is associated with the fact that you're bringing back, you know, a rocket and landing it right by, you know, the landing, well, where you took off. So that's sort of like the big risk. But instead, it gets getting held up by what they say are basically bogus environmental analyses. People are complaining that the water is a problem. Well, it's drinking water, you know, and it's hitting exhaust that's coming from a methane-fueled rocket, which basically just puts out carbon dioxide and water. I mean, it's like there isn't really a source of things like mercury and that sort of thing, other than this was in a drinking water in the first place. So they're complaining that it's really kind of bogus. It's just people are trying to slow it down.
And it was written, there was another complaint that there was a fuel spill, and that this was a major concern, and poisonous chemicals. It turns out that it's actually an oxidizer spill, which oxidizer is oxygen. It's what we breathe. So yeah, the cold liquid oxygen spilled on the ground, but then after a few moments, it evaporated and went back into the air, and it's just oxygen. It's not anything else. It's just oxygen. And so whoever wrote the complaint deliberately tried to conflate the situation that it was fuel and not oxidizer. And so there's some funny things going on at the EPA. It's like there's a big stall campaign happening. The other thing is were you going to say anything about the Maritime Commission?
Okay. You go ahead.
Well, just that the third thing is that they've said that, well, now they're worried about if the rocket doesn't work exactly the way it's supposed to and land on the barge, that it will go off course and it will kill some fish. And that means that now the National Marine Wildlife Agency has to get involved, and they have to buy off on the fact that some fish might get killed. But the worst part about it is that if anybody raises another complaint about another fish, a type of fish, then that resets the clock 60 days. The National Wildlife Service starts all over again with a 60-day delay, another 60-day delay before they have to reply to the EPA, which then has to sit and think about it. whether they want to give the license to SpaceX or not. So it's every day for the next 60 days, someone can send a complaint to the EPA and say, oh, by the way, have you considered the sand crabs? Well, have you considered the redfish? Have you considered the bluefish? Are there any other fish in Dr. Seuss's book? You know, they can, and every time someone complains, it resets the clock back to 0 on a 60-day period. So basically, it's an indefinite delay.
Yeah, and keep in mind that every other rocket in existence drops off its stages into the water. So, except for occasionally in China where they drop them on villages because they launch them from land. But other than that, anyway, also sonic booms during landing. That will happen apparently. I'm not sure how really serious it is, but I think the biggest one is the water deluge system. That one is just so bogus. Anyway.
They pointed out that it's the same as rainwater. It's actually probably true. The water that they're using in the deluge system is actually at least as good as rainwater.
It's
and
drinking
no
water.
one goes to jail or gets a permit gets written up for a permit for rainwater on their facility, except suddenly SpaceX. So. This is that upside down shower head thing that suddenly blossoms water out underneath the launch pad.
Yeah, protecting the launch pad and absorbing a lot of the sound too.
Water shooting up giant water. Yeah,
That's a technical term. Yeah.
Yeah.
Okay, so anyway, as I was saying, this is going to be unique because they're going to try to catch the booster back at the landing site with these chopstick kind of things. So they call them chopsticks anyway. Kind of related to this, though, Musk around the same time had actually said that he thinks they're going to be able to launch something to Mars in 2 years. Now that's uncrewed, obviously, and obviously it'll well, obviously they'll probably try to land there. It may crash, but at least they're trying to make progress in this.
Yeah, just getting there is because
Yeah.
there are probably 8 countries that are probably trying to send missions to Mars, and most of them failed. The success rate is real bad. It's like only a 45% success rate.
Well, especially on landings.
Yeah,
Yeah,
on
so
landers.
There's orbiters. I mean, yeah, China, India, U.S. We've all put orbiters up there. But landing is really tough.
Challenging thing just to get to Mars.
Hmm?
Have we put rovers up there on Mars?
Oh yeah, the U.S. has multiple ones, quite a few.
Oh, yes.
Yeah, we've never done it on the moon. We're way behind China on that one. But on the other hand, we definitely have done it very many times on Mars. There's at least 2 big ones that are active right now. There's still Perseverance, which has been there like, what, 4 years or 3 years or whatever. And there's another one called Curiosity. That's the one that's over. There's a huge mountain.
Mount Olympus?
I forget what it's called. It's not Mons, but it's a big mountain. They've basically been crawling up for the last 10 years, and they're just kind of working their way up the mountain. They've been there, it's close to 10 years. And they're getting spectacular pictures, and they're still uncovering things. I think, they're actually getting a lot of good scientific data still.
Question here. I'd heard that 6 starships were going to Mars. A,
I
is
haven't
that
heard of them.
correct?
I wouldn't.
And B, what is Musk transporting to Mars?
Well, I don't know, maybe another Tesla. I don't know.
Cash. You're right, I will here.
I mean, basically, it has to be something that is probably not really worth very much. I mean, that's why when they wanted to demonstrate something, I mean, you can just send up some bricks and sand in a rocket if you want to, but you might as well send something dramatic. I mean, they did a Tesla, so.
That would be really funny. Sends another Tesla.
Then another Tesla, yeah, why not,
You're going to turn us around the rovers? Oh, yeah. Oh, yeah, that would be hilarious.
Oh, okay, so moving on. SpaceX did have a Falcon 9 booster landing failure, and that was the first one in 3.5 years. They've done 268 landings of boosters. Again, keep in mind, nobody else has done this at all. So this is really something. But they did get grounded, and that was probably legitimate, but for a couple of days. Because when you get down to it, it landed. Basically, what happened is the thing landed. It was landing on a barge out in the ocean, and apparently one of the legs crumpled. It started tipping over, and we got flames, and they lost it. There's still an ongoing investigation of that, but that was not considered enough to hold things up. It might have briefly held up that Polaris Dawn mission because that was being launched on a Falcon 9, but they got past that pretty quickly. So there will be an investigation on that. But when you get down to it, that booster has flown 23 times. I mean, they're going to wear out. So, I think that you probably say, okay, metal fatigue, end of story. So the question is going ahead now, what is SpaceX going to do? Are they just going to fly all of them to failure, or are they going to try to be able to predict? Hopefully they'll learn. You hope they're going to run them to failure for quite a while, at least for the sea landings, so they get more information figuring out how to make the legs stronger so they'll last longer. They certainly would like to do that. So this is actually, but it's the first time it's happened. So this is actually look at it as data. They have a couple others, but this was the oldest one. This is the one. Actually, they've landed it 23 times.
But they got several more coming up behind it that are not quite that old, but almost. So I think the next thing is 25. So I think the interim goal is to get to 25, and then they're going to think about pushing it after that 30 plus. We'll see. We'll get there.
Yeah, I mean the goal is to keep last forever, and obviously they won't. Nothing lasts forever. Okay, then there's sort of a sad story of the mobile launcher for the SLS. Now that's the Space Launch System. That's the big rocket that is used as the center of the Artemis program to get people up, up in the air. That's what's planned. There's some story behind it, but I have to go back into what is a mobile launch platform. Well, first of all, it's a thing that looks like this thing on the left, where there's basically a giant, set of treaded vehicles there. It's just a giant tractor with a base, and then a rocket sits on that base, and that's.
Rockets generally.
Oh yeah, well on this, yeah, because otherwise it would be a whole lot longer. Yeah, the Russians go the other way. They take things up on a rail car, and then they tip the whole thing up. But this is a long way from the vehicle assembly building. So once they've made the decision, we're going to put things in a vehicle assembly building because it's a controlled environment. It's probably safer from hurricanes and stuff. Then you got a problem. Well, if you're going to stack the rocket there, putting all the parts together, how do you get it out to the launch site? Well, this is what they do it with. And the thing is, it does include the tower. It's not shown in this particular picture, but there's a tower there too, which you kind of need because otherwise the whole thing is so tall, it may tip over too easily, and that gives you a little extra, extra capability there. So but anyway, the platform includes the tractor, it includes that base that's there, and it also includes the tower, and that's what the tower looked. That was from a 2015 picture. That's what the mobile launcher looks like. In that case, the tractor had actually already gone away. It's not in there anymore. You can see some daylight through there. Anyway, so this was built. The first one was built actually back under the Constellation program a long time ago, which had gotten canceled. It was left over from 2010. It upgraded a little bit, and it's been used. The Artemis 1 mission used this, and the next 2 missions will as well. However, they're upgrading the SLS. It's bigger and heavier and taller, and this just won't work for that. So they needed a new one. This one didn't work out so well. Bechtel was awarded a contract back in 2019 for $383 million to build the thing for delivery in March. Now, NASA did throw them some curves by having some changes in specs and so on. But anyway, the construction started in 2020, but by 2022, the cost had gone up to $1 billion, and the delivery had slipped to 2026. And part of the problem there is that they're on cost plus contracts, so they don't really necessarily worry about that so much. That cost was not their main concern, and the results kind of showed up. There was an audit report that just came out from the Inspector General, which is a NASA organization, kind of an auditing agency. They just issued a report on this, and they're saying, well, now it's actually going to cost, officially, it's going to cost $1.8 billion, but they made it pretty clear they think it'll probably creep up quite a bit higher than that, maybe as high as $2.7 billion. And it won't be ready until 2027, maybe 2029, depending on how things go. What was interesting is that NASA also, in their contracting, they do give bonuses, for doing a good job, which is not unusual. Lots of companies do that kind of thing. And so they had a pool of money they could use for bonuses. And out of all that pool over the years, they've actually given good performance bonuses. They've used up about half of that. So I would say that particular program maybe isn't being managed as well as it ought to be. So anyway, that's kind of a controversy going on right now. They blame mostly Bechtel, which is the main contractor here, and a little bit on NASA itself for not managing it better. But given the structure of the cost plus contract, their hands are kind of tied. Anyway, okay, different topic. The Viper Lunar Rover, we talked about this one before.
I also read that they talked about trying to make it a fixed contract. They said they fixed it idea that they felt like Bechtel was just doing an unrealistic margin.
Yeah. It might be true. Yeah, yes, it wouldn't be surprising. I mean, NASA's in a tough position at this point. That's already cost it blown up so much, but Boeing's in a tough position as well. Or not in Bechtel. I'm sorry, Bechtel in this case. They probably are going to be losing money if they commit to fixed price. So who knows? But anyway, these things go on. Okay, Viper Lunar Rover. We talked about this one in the past. This is the lunar rover that was going to go and do some prospecting for mostly ice, but water basically on the moon near the South Pole. First one to actually try to go down into the craters where the ice might actually exist and really prove that it's there or not there. Kind of a major thing if you're going to actually try to build any kind of bases and civilization on the moon at all. You're going to need to know this. But CrossSat also escalated on this for a variety of reasons. And NASA ended up killing it. Kind of surprising a lot of people that they did, because there was about $84 million left to spend out of the 500 or 600 million that was costing so far. Anyways, they had killed it. That did cause a lot of consternation in the space community. Most people didn't like that too much because they thought this was actually a pretty important mission, even for Artemis, and this is managed ultimately as part of the Artemis program. So NASA. They were originally just saying, well, okay, if you can respond, we'll give you a couple of weeks, let us know if you want to take it over. They relented and they said, okay, we'll give you till September 2nd to respond to give us proposals for what we can do with this thing. If you'll take it over so that it doesn't cost us any more money, you can have it. And they got 11 responses apparently, and I have not seen a list anywhere of who they are other than Intuitive Machines, a Houston-based company. They would like to take it. Now, they couldn't do it on their own. They're not really big enough. So they're looking for partners, and I think they're still actively doing that. But they did submit a proposal, and this thing would actually get there on their lander in 2027, if their proposal got accepted. I don't know how fleshed out all these proposals really are. But anyway, they're trying to do that. And independently, Congress is starting to raise questions. They have a subcommittee that monitors this stuff, and they have said they wanted some answers about this program. They want answers back on September 20th. So it's not clear what will happen, but what I'd say is there is still hope for this, because actually an awful lot of people, including me, think this was a fairly important mission. It may have been a bad choice in the first place to put it on the Astrobotic lander, which was going to go next year, very first mission. This is a fairly expensive piece of hardware to put it on a totally untried platform, the smaller version of which had failed recently. That was somewhat questionable anyway. So it's quite possible that actually, in a sense, NASA was doing everyone a favor, just not really realizing it. But maybe they realized that it was not going well enough at Astrobotic. You're never going to know the background on these things. So, I don't want to throw too much criticism at them, because they probably know a lot more than we do. And maybe actually this, in the long run, if they can get Congress to refund it, will work out quite well. The lander that was going to be used was from Astrobotic, and that'd be the larger version. Actually, NASA built it. They built it at Johnson Space Center. I'm sure there are lots of contractors involved, but fundamentally, this was actually their own product, and it was essentially done, other than mostly testing. And that's what they said. Part of the problems were that the lander, which was going to carry it there, that had gotten delayed multiple times. And when that happens, that always raises cost, because all the people who work on the project, you still have to kind of keep them employed, even though everything's been delayed. So costs just go up when things get delayed. And so that was part of the problem. But that triggered an automatic response. It looked like it was going to cost more than 30% over the original budget. That automatically triggers a need for a review and possibly going back to Congress. What people were questioning was, why didn't NASA fight harder to get this, so that, to get the money? And I think actually what may happen is they might, after all this is said and done here.
That 30% trigger, does that also happen with the option? Yeah.
Probably.
None
Well, there was an audit report on that. That's what I was quoting from the audit report there. It was big. You can get it. It's online. It's
I didn't know if they had to go get it reauthorized.
well, it's a cost plus contract. Okay. What I was talking about was under the CLIPS program, and that they definitely did, and that was definitely a criteria for that program. I don't know if that applies in general, especially if they've already done a cost plus contract by separate mechanisms. I don't know what the limits are.
Got fed up with solar back in the
Yeah.
1990s. Sam Nunn, Senator Sam Nunn, and they said, enough of this. You know, the project, we expect the company to give us a bid that's reasonable. Yeah, we'll make allowances for the fact that it's the first time this has ever been done, all that. But if you run 30% over very gracious allowance that Congress has given you, yeah, we're going to sit down and talk. And that's kind of the problem that they're running up against. If a company bites off more than it can chew, it can get into trouble, real big money trouble, real fast. And that's a high probability event when you're doing something that's never been done before. Or if you're in the situation of you're doing something that has been done before, but by somebody else who's probably dead or retired. Their knowledge will do you no good whatsoever. So you've got to start from scratch. And that's one of the big problems that Congress has. They think that we went to the moon once, why can't we just snap our fingers and do it again? And it's like, well, yeah, that was back in 1969, 1970. A lot of those people are dead now, or at the very least retired, and they don't grasp the concept of you have to keep the team of people together. They've learned things. Not all that stuff gets written down, and there's no way to pass that knowledge on. And so you need to keep your team paid, and that keeps them on the job, hot and running, and learning new things and doing stuff. And that's what SpaceX is doing way better than anybody else. Way better than anybody else. Uncle Sam. And so, and that they're keeping the knowledge current, they're continuing to learn, and that's why they are cost effective and why they're actually coming up with estimates that are realistic. Otherwise, you end up having to go to the cost plus contracts where the more money the contractor spends, the more money they get paid, and they have no real incentive to ever finish the contract. No Bechtel.
Yeah, no, NASA has a problem right now is that their budget has been pretty flat for a while, or maybe in real dollars declining. Things do have to get cut, and so maybe some of us would have thought it was a little bit hasty to cancel this particular thing, but fundamentally some stuff has to get canceled. The money is just not there without going back to fight for it. And there's just everybody says space is hard, and usually you're thinking technology, but the reality is the politics of space is hard as well. And there's always going to be politics because you're spending public money. And there's always going to be more programs you're going to try to do than you actually have money for.
Politicians are reluctant to spend money for any program that's not going to be finished in 2 to 4 years because they want to get the credit for that money that's spent. And if it's a program that's going to go on for 8 years or 10 years, then it's like, well, heck, I'm not even going to be in office anymore. Why should I spend money on that? So that is a reality, and that's what has to be dealt with somehow. You have to get congressmen who A, think they're going to get reelected, have a pretty good chance of getting reelected, and B, that the project is going to be done more or less on time.
Okay, probably better move on, or I'm going to run over my time limit here. Okay, other topics. We've talked before about the satellites communicating directly with your cell phone with the normal frequencies so that it's essentially transparent to you. Another step forward on this, AST SpaceMobile, they put up the first of their production satellites that'll actually do this. Now they had done prototypes, and prove it out with smaller, it was a smaller system, but now they're actually putting their actual satellites up. They'll need at least 45 to 60 to actually have realistic service. AT&T and Verizon are along with Vodafone and Orange and some others, are partners with them on this. And AT&T has at least gone on public record as saying that when there's 45 to 60, they'll actually make this part of the service. Now that way, initially, it'll be more or less what Apple has done with whichever Viasat or whichever company they've organized with, more for emergency messages than anything else. Basically filling in coverage where the land-based cell towers just aren't there. But the initial one, you can only do like an hour a day in the US. So it's really just up there kind of for test purposes. Yeah. Right. But that's for Wi-Fi service. Yeah, but that is a different thing. I mean, this is really actually your normal cell phone, 4 or 5G kind of signals. So, but as you mentioned, Starlink here, they are the main competition in this. It kind of came out of nowhere in a way. They had this agreement with T-Mobile to do the same kind of stuff. They already have 175 satellites up there that can do this now. So they're rolling it out much, much faster. All they did was they had to add extra capabilities to the existing satellites, and that's why only 175 of them, do this. But that's still a whole lot more than anybody else is going to do. So this is definitely coming, and it'll be interesting to see how it plays out because you got a lot of major cell service providers like Verizon and AT&T that would rather not be dependent on on Starlink if they can avoid it. So whereas T-Mobile is all in on it. Okay, moving. Oh, okay, sorry. How many they have up?
Yeah.
They just have their test satellite up now.
Okay, they haven't.
They have. Well, okay, there's two. There were two because they wanted to test out the and they did test out the laser links between the two.
Okay, yeah, I was just curious how far they were along.
Yeah, in fact, I'm going to talk about them later in a different context. But yeah, I mean, they have plans for this huge network, to rival Starlink, but they really haven't built it yet. And I think it's coming. Actually, the first launch is coming up soon. They started launching the real satellites. Okay, so kind of a step back here. We've talked about a lot of topics, in this news segment about basically expanding our economy and civilization into space. And what does it take to do that? And we've talked about all these topics I'm listing here, and we'll continue to talk about them because there's always progress made on them. Things like mining on the moon, on asteroids and other planets, also called in situ resource utilization. If you're going to go off and live off the planet somewhere, you can't just keep bringing stuff from Earth. It's just too expensive. You need to start figuring out how to live off the land. And that means, at a minimum, getting water, probably getting some metals, maybe some hydrocarbons, and also at a minimum, just getting material to build your habitats. Instead of bringing a giant steel structure with, portholes and stuff to look out of, you're probably going to be covering it with regolith, the dirt, from, say you're on the moon. You need it for radiation shielding. For instance, and when they figure out how to use it for agriculture, it'll take some chemical treatment, but at some point they'll figure out how to do that. Then there's manufacturing in space, and we've talked about a lot of those kind of things before too. You can manufacture things that you deliver back to Earth, and some of that's been done with pharmaceuticals in particular, and also crystals for a variety of uses, but also on the moon or from asteroids. You can make oxygen and it'll also make rocket propellant. Things like that. If you're going to expand into space, you have to be able to start doing it from space because it's a lot cheaper to ship it, from an asteroid or from the moon than it is to ship it from Earth because the gravity is just so much more. Agriculture, forestry, space-based solar power is another one, that you need to basically get a lot of power available to you, and you're going to be using solar cells to do that, as well as nuclear reactors of one sort or another. And also taking a step back, part of this whole process is simply even just satellites. We talk a lot about different kinds of satellites up, and it's not because people are in them, but it's because you're building an industrial capability to support activity in space. And it didn't matter what there are. They could be spy satellites. They could be, used for monitoring agriculture. They could be monitoring the climate, and all these things are being done. But the fact is more and more of that is being done, and we're getting more dependent on that. But in the process of doing that, we're improving the reliability of rockets. Hardware costs are coming down drastically, and we're building experience on how to operate in space. Even when people aren't there, just even making sure the machinery works, because the machinery doesn't work, the people certainly can't live there because they depend on the machines. So all that is really, kind of reaching a takeoff point. And I've actually taken some pictures from out of some of our previous, discussions, like mining of an asteroid. We're sending the Psyche mission to go and do some prospecting there. It's a huge metallic asteroid. Space-based solar power, solar cells being built on the moon. Actually, Blue Origin says they can do it. They've actually worked out the technology. In general, having structures, solar cells, having a little bit of agriculture, all that kind of stuff. And that was actually a particular company's manufacturing process where they were making pharmaceuticals or crystals in space and then bringing them back to Earth and figuring out how to do that cheaply. So all that's happening. But there's a new one, kind of a new kid on the block that I have to admit I hadn't thought of until recently either. And all of a sudden it's made some news. Data centers in space. And immediately you're going to think, what? Why would you do that? Well, actually, there's a lot of power needs from them, and they are growing very, very rapidly. They're taking more and more power. Now, the European Union, in one of their studies, estimated that there's probably going to be about 23 gigawatts of power consumed by 2030. I think a lot of other people think it's a lot more than that. And a way to look at this is, what is this? Well, that says you're going to collect solar energy up in orbit, and instead of sending it back to the ground, which is the thing in space-based solar power, and which is the hardest step in that, why not just consume the power? What gets generated in space stays in space. All you have to send back is the information. You don't have to send the power. And this actually might be, in my mind, this actually could be the first practical, large-scale solar use that could happen in space, because we already know how to do all this stuff. It's just a matter of scaling up. Whereas transmitting the power back, that's a much harder problem. You got to convert it to microwaves, send it down, have square miles of antennas on the ground, which we probably wouldn't even be able to get permits for because people are afraid of it. That's all just going to take forever. This actually could be a much more rapid way of getting things going. In terms of why do data centers come in? The biggest single driver right now is training AI. And now, in my mind, actually, there's what's called the hype cycle put up by the Gartner Group, where people get really, really excited about technology, and then they have these wild initial enthusiasms, and a lot of money gets spent, and most of it is wasted. And then people get realistic, and then the enthusiasm goes down. But then over time, it drops off, but eventually then it kind of goes back, and eventually will come back up much further in the future. Most technology goes through this hype cycle, and I think right now we're already past the peak on that one, where people are saying, wait a minute, this stuff, it just doesn't really work that well. And nor can it. So, but it doesn't matter. Right now, it is a big driver for data centers. I'll give you an example. Not even counting the AI training, Amazon Web Services. They just bought a data center from a power company in Pennsylvania. Actually, it's Talon Energy, which is a Houston-based company. There's a 2.5 gigawatt nuclear plant in Pennsylvania. That might be the biggest one in the US. There's a building, I've seen the aerial picture, right next to it, there's this big data center, and it had been started by that energy company. Amazon's going to build that out, but they're going to take a gigawatt. But
Where's that located?
Susquehanna, it's some little town near Susquehanna, Pennsylvania.
Okay.
It's pretty rural. I see the aerial pictures, there's just woods all around it with big power lines, heading out from it. But so this thing, a typical nuclear power plant in the US is more like a gigawatt. Its capacity is that. And this is actually an unusually large one for the US. The largest ones are maybe 5 gigawatts. At largest is actually 8. But those all exist in other countries. But anyway, this is a big one. But the point is they're going to consume a significant portion of that entire nuclear power plant output. And this is not unusual. People like Meta and all these other companies, they're frantically looking for sources of power. And of course, they all want to have green power, and at least there's no carbon dioxide generated by the nuclear plants, so they're especially favored. But they've pretty much used up all the hydropower and all that kind of stuff. There's some town in Texas where people are complaining about that they're using it for crypto mining, and they essentially have their own power plant. There's a lot of this going on, you just don't realize. But cloud services in general are generating a lot of need for this. Now, I think there's probably other examples that are better compared to AI training. The problem with AI training is that you need a lot of information. Basically, a lot of data has to go up to, is the training data. That's a huge amount, and that's going to be a bottleneck. So I think that's actually not going to be the best model. The best model will be things that take a lot of computing time, but don't require a whole lot of data. Well, cryptocurrency mining, that's the big one. And that's also been consuming vast quantities of energy. And also just large-scale simulations, people doing weather or climate studies, or even engineering design. There's huge amounts of power going into that right now. And actually a lot of that could be handled up there. And there's also examples of data that starts in space. All the satellite, for instance, all these satellites that are observing Earth, they're like taking pictures or radar pictures. What do they do with it? Well, there's way too much of that for a person sitting in an office to look at. They have to have software that kind of scans over it, looks for patterns like changes, say, okay, we see now that there's 3 Russian tanks here instead of 1, and that kind of thing. Or we see that there's a whole lot more ships suddenly diverting from their normal paths because they're avoiding being shot at by the Houthis or something. That kind of stuff is going on all the time, but it takes a lot of analysis, and that's being done by software. That can just as easily be done there. And again, you don't even have to send back as much information. You don't need to send the entire pictures. You can send the analysis for the 5% of them that actually are important. So anyway, those are all good examples of things that could be done in space. So what?
That's the CIA analysis in space.
Yeah, but it's also every other kind of thing too. I mean, there's an awful lot of climate monitoring kind of stuff. There's just an awful lot that goes on. The weather alone. I mean, that's a huge thing, and that takes immense amounts of power. When they do all those calculations on hurricane paths and stuff, that's an immense amount of computing. So the arguments are, well, there's really no pollution. I mean, again, what is generated in space stays in space. There's no pollution. There's no greenhouse gases. And there's no cooling water usage. That's actually pretty significant in some places. You got a big cooling towers. There's a lot of evaporation off of cooling towers. If you're in the middle of a desert somewhere, you don't have a lot of that. So that doesn't work so well. So what do you compare it to? Well, you compare it to terrestrial solar power. Turns out it's much more efficient to do it up in space for a variety of reasons. The biggest single one is just the day-night cycle. You're not generating power at night. You go up in a high enough orbit, or one I'll talk about in a minute. You go up in a high enough orbit, and you can operate 24 hours a day or close to it. That's a 50% factor right there. Seasons, weather, and just the atmosphere itself attenuates. It degrades the stuff. It basically ends up re-rating as infrared because it gets absorbed by the air. So that's calculated by a capacity factor where you say, okay, there's a nameplate capacity, which is what you can get, peak day time, noon kind of numbers. You actually end up with about 24%, compared to the nameplate capacity in the US. Actually, Northern Europe only gets about 10%. So the claim of, there's a company I'm going to talk about, they say on average, it's about 5 times more efficient to get your power generated in space than it is by doing the same solar power down on Earth. So,
a solar array to generate a gigawatt.
Yes. I'll get to that. Oh, we're talking square miles, but you have it in space. So, part 2. Now the next comparison is, well, what about space-based solar power? And I alluded to this a little bit already. You have a big array of solar cells up in space. You convert them to microwaves. You send them down to a giant antenna where literally it's square miles. I mean, 7, 8 square miles are the typical kind of things. It's called a rectenna. It's a antenna plus rectifier where you generate DC. And then from there, you have to convert that to alternating current to then feed back into the grid. There's a lot of inefficiencies along the way, and it's a lot of land, a lot of permitting, and all that kind of stuff. It's basically, that is the hard step right now. The technology hasn't really even been proven for any significant distance. But yeah, you can do it for a mile or something, but it hasn't really been demonstrated on any scale yet. So there's a lot of uncertainties with the technology. The good part about this is space-based solar power, but not transmitting it down, which is the hard step. You're not really constrained by physical limits, not really, not like you are on Earth. And it's easier to control because the environment's a lot more stable too. You can do temperature control a lot more. Now the European Union has taken interest in this. They have a project called Ascend, which, it's an incredibly long acronym, but basically they're interested in doing this. And so they put up some money to do feasibility studies. Now I think their goals are extremely timid. Like they're hoping that by 2036 they can get an operational system, and by 2050 they could do a gigawatt of capacity. This is not anywhere near enough, but it's what they're doing. At least now they are partnered with Microsoft, and they've already issued their first report, which basically said this looks good. Let's do more study. So it's just like a classic academic study, right? That's the last sentence in every academic study is further research is needed, but it's true. I mean, I think there's something to it. Now, what's interesting about them, though, is their emphasis is really on the environment. That is, it's part of what they call the Green Deal. So what they're saying is it doesn't really have to be economically viable. It just needs to get rid of a lot of pollution or greenhouse gas generation on Earth. And also, there's a subtext. It actually said it, though. I was reading some of their documents. That they've fallen way behind in the rocket business, the launch business. They don't even have a reusable rocket yet, and there's a lot of thought that they shouldn't even bother, because basically they're just going to go with what they have, which will always be more expensive, but they'll at least they'll have their trained core of of engineers and scientists that know how to build rockets. So they got two major incentives that actually don't even involve economics. So I think there's and there are companies involved in this. It's led by a group called Thales Alenia Space, which is a Spanish version of Thales. A lot of people here might not have heard of that. Actually, they built a lot of stuff that we put, like the Bishop Airlock. They're the ones that actually do all that heavy-duty metal work to build these big vessels. The Bishop Airlock, the Axiom space station. There's a couple of Houston companies right here that are actually getting a lot of the work done, and that was by the Italian subsidiary. But anyway, Ariane Group, which launched, they were the ones that sold the rocket launchings, Airbus, and so on. Hewlett-Packard Enterprise. Oh, where's Sonia's gone? That's too bad. She'd be thrilled to know that somehow they're part of the European Union. Okay, anyway, but there's been interest by private companies here, which I think will actually be far more important. There's a startup that just got going at the very end of last year, beginning of this year. They have a plan to put up 300 satellites to process data in space, and they're going to launch a demo in May 2025. And they say they have a paying customer for this already, and maybe several others that might do something. And they actually hope that by the following year, they could create at least a portion of the network. Now, what's interesting is they put out a white paper this month, and that's actually what drove this presentation. That actually is much more visionary. What their business plan is a bunch of little satellites in very, very low orbit. What they're now saying in this white paper is have the gigantic station, and that's a 4 kilometer by 4 kilometer array of solar cells there, which is the same kind of thing you need for space-based solar power, but they're just saying in the center of that, just put your computer. So they put this white paper out. Their goal is to have a 5 gigawatt data center, which is like a very large nuclear power plant. And that's the one that would have the 4 kilometer by 4 kilometer solar array. Now, what's interesting is how they're going to do that. And what they're doing is they're saying, okay, half of the Earth is always illuminated by the sun. You want to be there. Now, one way to do that is to be far enough away from the Earth that you're never in the shadow of the Earth. You're never covered up. But the other way to do it is to be in an orbit perpendicular to that, so that the sun comes in, and no matter where you are, or at least if you're close to that orbit, you're going to go ahead and get power. And that's actually possible to do with what's called a sun-synchronous orbit, and that's what they're proposing. Here's a picture to explain this. Your eyes may glaze over at this, but it's actually not as messy as it looks. You're looking down. Imagine that the Earth is going around the sun there. The blue thing is the Earth. And it's doing it. It forms a plane, and that's this flat screen right here, and it's going counterclockwise. That's what that little arrow over there means. And they're just showing you the yearly path of the Earth. So there's 4 different times where they've taken a snapshot. Now you can have an orbit. This green one here, it's not actually exactly perpendicular, but if it's close to that, most of the time you'll be exposed to the sun. And the thing is, that's in that position. But by the time the thing rotates, it has to be in a different position to do that. And the way it does that is that, well, it says that the Earth goes around once a year. Well, this orbit has to go around the Earth once a year also. And if you do that, that's called a sun-synchronous orbit, and they can do it. And they can do it hovering right there on the boundary between day and night. So they're talking about that. And that's up at like 800 kilometers, kind of where the, just below the Van Allen radiation belt. There is a video of this, just to give you a sense of the scale. The problem is I just missed the whole thing, but so there's a data center there in the middle of this giant thing. That was it. That's just basically their very short ad. Yeah. And that's true for all the space-based solar power stuff. You need, really big arrays. One way or another, you need a lot of solar cells. And it just seems like, well, this might be a reasonable way to get started with it. So, we're almost done now. Now, a question came up before about Amazon's Project Kuiper, which was their network of satellites. Probably they're going to get involved in this one way or another, either Amazon directly or in Blue Origin. And they are, to some extent, already involved because Axiom Space, they're the ones that are building an attachment to the space station, the existing space station. And then eventually, when the space station goes away, they'll still be there. They are going to put a data center in there. And they're integrating that with Amazon Web Service. So Amazon is involved already to some extent. That's going up in 2026, 2027. It's already going to happen. It doesn't take any big R&D effort. They're just going to do it. And what they'll probably do is just tie in with with their network if Amazon gets it built fast enough, which is still not very clear. But certainly they could always go through Starlink if they had to. Actually, other entries are in there too. Japan has a couple companies, all that are kind of interested in this stuff. All right, so there are challenges with this, obviously. Maintenance. How the heck do you maintain the thing? Well, basically, when pieces fail, you just have to be able to move them out and drop them back in the atmosphere or bring them back. So that means they have a very modular architecture, and they'll have to have robotics to do this. You're never going to be able to have a bunch of astronauts up there maintaining this stuff at any reasonable cost. The environmental issues are probably the biggest one. I mean, you're going to generate some orbital debris just from the launches. There could be collisions, all that. Actually, vulnerability to attack. I think that's actually going to be the biggest single problem, is that you're just putting a lot of money into something that's very easily destroyed. And you're at risk, and the way the world is heading, we probably are going to have, kind of limited warfare in space, and something like this would be a big target for that. I don't know if this is really a serious issue, but there's a heck of a lot of radiation that gets infrared that has to get dumped by the radiators on this thing. And how much? Well, exactly the amount that's generated in power. You got all this power being generated by the solar cells. Essentially, all of that has to be radiated off. It's just an energy balance. Otherwise, it'll keep getting hotter and hotter. So that's a lot to dissipate. Now, they're going to radiate it, not all in one direction, but a lot of it might not be 360 degrees. It's going to be directed in some direction. And if you're really close to that, that could be a problem. Cost, of course, is still the big question. That 5 gigawatt unit, the computing plus the solar power cells, might take 200 Starship launches. So you're not talking small scale. This only is practical when you have much, much cheaper access to space. And that's what Starship is promising, but of course it isn't there yet. So all of this is really depending on that. The radiator area, which is what's going to reject all this heat into space, that's about half the size of a solar array. So you got this big area of solar cells. You've also got to have a lot of radiator. That's a lot of cost. Shielding for the electronics, because you're up, you're getting pretty close to the radiation belt there. And also you got to get the chips, which are actually the thing that are hot in the computers. You got to get that heat transferred ultimately out to those radiators. How they're going to do that, not clear. You're not going to use cooling water. It's too cold up there for that. So how they're going to do it is not clear. And maybe transmission delays. Yeah.
How practical is it to create enough shielding that you don't have?
Yeah, well, you have to have no shield. Well, I think they're just going to have to get experience with that. But we have a lot of experience with computing in space. Even on the space station, there have been small data centers put in. Actually, Microsoft did one a couple of years ago, just with servers. And they're using, and people up there with laptop computers and everything. So at the level of the space station, it's apparently not that bad. And they're going up a little bit higher than that, so then that's more of an issue. But that's why you're never going to build the whole thing all at once. You're going to build small scale in modules, you're going to have, you know, some solar cells and some computing. If that works, then you're going to expand it. And there has to be a modular approach. It's not, it can't be all or nothing. Okay, the last thing is just what's coming up in the launches of space. Well, a big one, of course, is the crew going to the ISS with the 2 empty seats. We talked about that last time. This is because of the Starliner problem. Hera, that's an interesting one. Remember, we went and we blew up an asteroid, sort of, as part of it was the, you know, the planetary defense kind of studies with the DART mission. And so there were pictures taken of that, but everybody kind of wonders, well, okay, what's that like, you know, a couple years later? Did a lot of those blown up pieces kind of come back together? How badly was the asteroid itself damaged? The Hera mission is going to go find that out. They're going to go take pictures of that asteroid. So that's an interesting one. The Europa Clipper is a big one, heading to the Jupiter's moon. We've talked about that a little bit. That's coming up pretty soon. Blue Origin, their New Glenn first flight, probably November. Originally it was going to be October, and I think now it's slipped to November. Now, one thing that's happened is NASA got nervous. There's a couple of small satellites that were actually going to go to Mars being launched by the New Glenn. You know, obviously they had their own spacecraft to get them, you know, once they got past where the New Glenn could get them. They pulled back on that. They thought it was just going to be too risky. They were, in particular, they were worried about schedule. They were afraid that they wouldn't make it on time. And Mars is a place where there are optimal times to get there. Every 2 years, you got a window when it's really easy, relatively easy to get there, just based on the orbit of the Earth versus Mars. And that's every 2 years, and they were afraid they wouldn't make it. So NASA pulled out of that. Starship, we talked about the Flight Test 5. That'll come no earlier than end of November. Now, there's another lunar South Pole mission coming up from Intuitive Machines. That's going to be probably January. And we're still waiting for Dream Chaser, which is another alternative for getting to and from the space station. And we still don't know when that's going to happen. That'll just be for cargo, not for people short term anyway. That's it. Any comments on it? Okay. Well, thank you. And now it's time for Christian, and I will get his slide up here. I won't introduce you because we've done this you've already done this a couple of times, but he's an old regular here, and I'm
yeah. I'll just take your microphone.
Oh yeah, good idea. Okay.
All right. Thank you very much, Greg. And now we're going to take a different look. We'll take a look how we got here, how rocketry actually happened. And maybe, Greg, we can learn a few lessons how to actually get to the moon a lot faster and easier, right? Because in the past, we did do that a lot quicker. Right, so the rise of the rocket and the origins of the space race. So we'll talk about the Congreve rocket here very quickly. Some of the iconic pioneers in space travel. Then the unintended consequence that guaranteed rocketry. So there was a political thing that happened that made sure people would focus on rockets. We'll talk about World War II and what happened after World War II. All that knowledge that was built up. The Soviets and the Americans took charge of that. And then what the legacy is. So let's get going. So the Congreve rocket, that guy there is Sir William Congreve, a Brit, who claimed he developed a rocket. Well, this is not true for two reasons. One is the Chinese are known in ancient history to have developed solid fuel rockets. And second of all, the only reason he knew how to make those rockets, he claimed to be Congreve rockets, is because he took it from Tipu Sultan of Mysore, India. So the Brits were fighting the last pieces of local Indian control. Tipu Sultan's actually one of the famous heroes of Muslim India fighting against the British. And one thing Tipu Sultan had was he had dedicated rocket corps in his army. He had whole battalions of rocket launchers. And for the first time, they had metal casings. So these were very durable rockets, and they would launch, and they had a devastating effect. By coincidence, I've actually been to this place, Seringalpatnam, where he lost. And when I was there, the fortress had more or less been razed and abolished. And I was told, yeah, there was a magazine explosion. What I did not know, the magazine was full of rockets. And so there was nothing left standing anymore except for his own little palace on those grounds. So the Indians massively used rockets for the military before the Europeans even figured it out. So unknown origin of rocketry, right? A little bit of history. Now, Congreve used these rockets against us in Baltimore. The rockets that were launched from British ships to Baltimore were Congreve rockets. And for that, we now have it in our national anthem that we're dedicated to rocketry, right? I mean, no other country in this world has it in their national anthem, right? So we better do something with that claim, right? All right, so who were some of the iconic pioneers? We'll quickly go through that. Most of your names should be familiar, like Konstantin Tsiolkovsky. He was a Russian of Russian-Polish origin. Interesting enough, he became deaf very early on in life. He could not hear. So maybe that's why he was so focused on developing the rocket equation, i.e. how much mass of fuel you need to push so much mass of cargo up into space. And he was the first guy who thought about the space elevator. This is a favorite program of the National Space Society and many other people. But he thought about that originally. And you know, that's 1900s. That's pretty early. So one of the big pioneers. Then going the same place, Sergei Korolev. He was actually the big driver of the Soviet moon program. And his death in 1966, a lot of people say probably prevented the Soviets from winning the space race. Now you can debate that, but certainly was a blow that set the Soviets back. He was there from Brown. Interesting enough, his mother was Ukrainian, his dad was Russian. Wonder what they'd say about that today, right? And then a very little known person, but I put him up here, Robert Esnault-Peltier, French. He actually did develop very early on liquid fuel multi-stage rocketry, but was not supported by the French government. So some things never change, right? Not being supported by the French government. Now, this is all interesting because now we're getting puzzle pieces. And what was happening then, these people were not developing in isolation. These people were all talking to each other. Like the next folks. Now we get closer to home. Hermann Oberth. Now, if you want a really interesting origin, he was officially born in the Austro-Hungarian Empire, which is now today Romania, of German parentage and German language. Now, he's one of the big theoreticians, and he came up with a lot of good ideas. Your space mirror concept, the lunar car, and the electric ion drive. He laid down a lot of the theoretical groundwork for that. And you can see him here sitting at NASA with some of his other colleagues. So big name of rocketry. Then probably the biggest name in history, Wernher von Braun.
Biggest name, Walt Disney?
Yeah, Walt Disney was there. Now this is where Wernher von Braun was an extremely good physicist and engineer, but where he really excelled was communications. And that's probably no coincidence. He should be placed together with Walt Disney because he really made space travel popular. And he was very effective in front of Congress, very effective in front of politicians, getting support and the funding that the program needed. And so this is a good photo to have here. So he was German American. His birthplace nowadays is in Poland, and he led both the German V2 and the U.S. Apollo space program. We'll talk more about that. And then last but not least, Robert Goddard, American, also did a lot of work on multi-stage rocket and gyroscope development. Now, this was really important. A lot of people could make a bang with a rocket, but not know or control where that rocket would go. And it's verified that Wernher von Braun, before World War II, actually communicated with Robert Goddard and said, well, how do you control a rocket? And got a couple of ideas from him, right? So these people were all communicating back and forth with a big international effort. And there was more going on beyond science. Science fiction started to take off. Now, Jules Verne is the big grandfather of science fiction, right? In the 19th century, a lot of great books he wrote, but the film industry started to pick up. So here we, for example, have a German movie called Frau im Mond, or Woman in the Moon, by Fritz Lang. Fritz Lang then became a very important Hollywood director. Right? This movie was considered such a huge success as to be the first serious science fiction movie. So that's what you also want to do, is get the public enthused, right? Make it more tractable, give it a more emotion, give it a storyline, right? The woman to the moon, basically. So that's very nice. It was all happening at that time. So what's the event that supercharged rocketry? Anybody want to guess?
World War II.
Nope.
Oh, is it like
No. What forced Germany to develop rocketry? Actually forced them. The Versailles World War I peace treaty. So that was a devastating peace treaty after World War I. You no longer develop aircraft for military purpose. You no longer develop submarines. You can't have a battleship anymore. You can't develop tanks, and no heavy artillery. No heavy artillery? You mean like this here? Yeah, you're not allowed to have heavy artillery. Well, apparently the politicians of the Versailles Peace Treaty were not fully aware of all military technologies out there, right? So of course Germany found a way around it. What happened here is we actually had the military, and that's highlighted here by this Major General Walter Dornberger. He was a PhD in engineering. And in 1930, he tried to find alternatives to artillery. Coincidentally, at that time, Wernher von Braun was graduating from university, had written his PhD on rocket drives. The two got together. So Braun had the ideas, and Dornberger said, well, I can get you a lot of money. Right? Now, this was pre-Adolf Hitler. Right? So this was civilian democratic Germany. So Wernher von Braun was a member of this Verein für Raumschifffahrt, VFR, Society for Space Travel. And Dornberger became the military head of the V1, V2 programs. We see him here. Actually, no, this is the guy. That's Dornberger. And he was also the head of the Peenemünde facility where all those German rockets were built. And that started before World War II and had 6,500 employees. Now, unlike today, Peenemünde was completely vertically integrated. Everything was made on site, everything was designed on site. You did not have to branch out to 100 different suppliers other than for simple components. It's vastly different to what we do right now today. People develop things quickly. People change designs quickly. People manufacture different designs very quickly. They completely understood the design as well, because the engineers had to go down to the shop floor, make the pieces, fix the drawings, which were always wrong because they were never up to date. So it was this combined force at all levels that was actually making very rapid progress. Now, Dornberger, not only having worked here for the German military, also became vice president of Bell Corporation for the X-15 program, and was a leading member of Boeing's X-20 Dinosaur program, worked with the U.S. Air Force on guided missile technology. So there's already a clue what the next slides are going to be about, right? Well, one more fun fact, and I'm going to bring the National Space Society in here. So the Verein for Raumschifffahrt has been renamed the Deutsche Raumfahrtverein, and I looked up their website, and they specifically say they are the Verein for Raumschifffahrt, and they are an associated chapter member of the National Space Society. So we can claim through some ancestry chart, right, that the NSS was part of all of this. All right, there were also other people here. Eugen Zenger, he was Austrian, born in what's today the Czech Republic. He actually competed against von Braun. So when the Nazis were doing things, they were working on very many different initiatives. And one of his big initiatives was very familiar in concept to what we have already built. He was a glider expert. Remember how Germany was not allowed to build military aircraft? They built great gliders, like this one. Does that look something like a space shuttle? So the concept was born early in World War II, but only executed until much later. So he developed the idea for the lifting bottle shuttle rocket, called it Der Silbervogel, or the silver bird, but it doesn't look very silver to me, but that's okay. After the war, he actually set up the Fédération Astronautique in France and developed rocketry for the United Arab Emirates. So that knowledge was spreading out after World War II quite a lot. The other things he worked on was his Horten 229. Some people might have seen something similar in Captain America. It's actually not too far from the truth, but a lot smaller. In the 50s. So definitely very futuristic looking, no tail structure at all. All right. So what did the Nazis create in terms of rocketry and advanced aerodynamics that we draw on today? This is a radio-guided bomb, but there was a version with a radio-guided rocket engine as well, the Fritz X. They used that a lot against naval targets. They sank the Italian battleship Roma with that, and quite a few other vessels. A true rocket plane, the Comet, the Me-163, it flew. But I would never want to be the pilot in that because you had 5 minutes fuel, and then you had to get out or glide back. It was actually a glider on the return back. It did not have wheels for landing. So, I mean, this is a really scary aircraft, right? So the wheels were used for takeoff, but they would be dropped off after takeoff, and you would land on what was actually a reinforced steel rail you can barely make out on the bottom. You had to be a brave person to fly this. Probably.
The other point, hypergolic fuel.
Yes, they developed hypergolic fuels for that rocket plane. Exactly right. We still need them for rocketry today. Yeah, go ahead.
Plane catch on fire when it
Yeah, if
lands?
you just speak up.
Speak up.
Microphone.
Wouldn't it catch on fire if it lands?
Wouldn't the plane catch on fire if it lands?
Because of the friction.
It didn't, but because of the hypergolic fuels, you had to have two components to put together. Very often at fueling, the plane would explode. So this was really, a suicide kind of airplane.
Yeah, it was at the end of the war when they were desperate. It landed usually on a grassy field, so yeah, it wasn't catching on fire wasn't a problem unless they had a little bit of fuel and oxidizer left. At which point, when you came in for landing, hit hard a couple times, bounce, the fuel lines could bend and break, and when those hypergolic materials mix, 4th of July. It killed more pilots got killed in testing than killed the enemy, than killed Americans.
Well, nobody could shoot down one of them because they were just too fast and gone too quickly. But yeah, it was wild. Now it did work.
Yeah.
Sometimes.
It was a screamer.
So what are the other things? Now, very unusual, and you can find this here in Washington, D.C. in the museum, is this anti-air, surface-to-air rocket. Was developed in World War II called the Wasserfall or waterfall. And here's a picture how it was actually used.
Is that the National Museum in
No, Washington, D.C. So they did that. This is another surface-to-air missile. It's at the Smithsonian, called Rheintochter or Rheindaughter. Beginning to look fairly modern, right? Then we have a guided missile fired from a U.S. submarine. That's actually a V-1 copy. And the V-1 was basically the forerunner to the Regulus missile that the U.S. Navy developed in the 50s. Then, obviously, everybody knows the V-2, right? The big rocket that was launched. A lot. So, a lot of technology was developed in 4 years, 5 years, very short time frame, but they threw money at the problem, right? So, after the war, everybody was interested in saying, how do I secure this technology? Because neither the Soviets, nor the French, nor the Brits, nor the US had that, right? So the first ones off the bat were the Soviets. And the Soviets might have had a bit of an advantage because the main two production sites for rocketry were all in the Soviet occupied zone in what became East Germany, Peenemünde and Dora. And they could secure a lot of scientists, they could secure a lot of materials, but before they entered their final occupation zone, American troops entered Dora temporarily. And within 2 weeks, they had cleared it all out. Now, this was a huge operation because Dora was making 400 rockets a month. So Elon has got a target he's not matched yet. 400 rockets a month. I mean, the big ones, V2s. But there was still enough left over for the Soviets to pick from. But the U.S. picked 100 complete V2s and tons and tons and tons of components. They all went to White Sands and got tested. White Sands, New Mexico. Where, by the way, in some of the tests in White Sands, the V2 copies or originals actually passed 100-kilometer altitude, so became the first official space vehicles.
Secured 100 V2s. Is that the polite diplomatic term for what they did?
Well, was basically raid and run.
Yep, looted.
Looted. So the Soviets, they called their operation Osavyakim, I hope that's somewhat correct, and they hauled 2,500 German specialists plus 4,000 family members east against their will. That was actually a really neat story, so they invited them all to East Berlin for a celebration, and for once, the Russians were not drinking, but the Germans were. They went to bed, and at 3 a.m. they were hauled out by the secret police and put on trains to Siberia. It's actually a true story. Because nobody really wanted to go on their free will to Siberia, right?
Oh, yeah. The Germans were scared witless at the end of the war of the Russians. And the whole notion that any of them volunteered to go to Russia is laughable.
Right. And it took a long time for them to get back. Some were released in 1950, but the last ones came back 1958, 13 years after war ended. However, the Soviets denied they got much help from German scientists. There is no German DNA in the Soviet rocket. I'll let you be the judge of this. This is the first Soviet rocket. The SS-1 Skunner. It does not look at all like a V2 rocket, does it?
No.
Less well known is this Messerschmitt P1011. Does this look like a MiG-15? Getting pretty close, right? So whatever it might have been, they certainly did get some designs out of those people, I'm sure.
Yeah, the thing is, scores of factories went east. A lot of people don't realize that the Russians literally came into Germany and they took entire factories. I mean, they took the buildings, not just the contents. They took the buildings too,
including the
including
the toilet bowl.
Including the toilet bowl. Yeah. They didn't have toilet paper in Russia until the 1980s.
They didn't have toilet bowls.
Yeah, well.
Anyways, so a lot was happening on there. The Soviets officially deny what help they got, but I think this looks pretty convincing that they had a start. They had some help. On the other side, Operation Overcast and Operation Paperclip. The word Operation Paperclip is pretty well known. Overcast was its forerunner. That's how Von Braun within weeks got into the U.S. and some of his close followings. And this was difficult because this was actually against American law. They could not get a visa through the State Department, so the Department of Defense smuggled them and told the State Department, you want to do something? Try. So there was a bit of fighting going on there, and President Truman actually had to sign off on this action. It was not really according to the rules and regulations. Pretty amazing. So 1,600 German specialists were hauled over, and I guess those are some of them. And maybe we're a little bit more honest, but we're thinking we got $10 billion worth of patents and earnings out of all of those people there. Now, there are two different authors who are saying that, so I'll say it's somewhere in that order of magnitude. How they calculated it, I'm not sure, because a lot of patents you do for the U.S. government, you can't sell or make royalties off, right? They stay within the U.S. government completely. But there was probably some really good advancements there. But it was not just rocketry that went over, but electronics, material science, medical, chemical, because you need all of that for space travel too. It's not just the rocket engineer you need. You need all the other engineering specialities. Right, and many awards were handed out, right? So some of the names here, all pretty famous. One person I'd like to highlight here, so in the Space Camp Hall of Fame, there used to be a guy called Hubertus Struckold. He was a medical doctor. He was inducted and then removed because he had done extensive studies on hyperthermia in a concentration camp. And so some of our knowledge at NASA on how the body reacts to hypothermia were the result of these very unfortunate torture experiments. So recognize that, and it took the honor away.
Hans von Opping invented the German version of that engine, and it's the more popular version that is used today everywhere around the world. He ended up working in Dayton, Patterson Air Force Base.
Right. Exactly. And then there's some interesting things going on here, like the Department of Defense gave Siegfried Knemeyer a Distinguished Civilian Service Medal, but he was also the holder of the Knight's Cross of the Iron Cross. So that takes a little explaining there, right? But let's go to the big hero of the story, Wernher von Braun. He's the larger-than-life character. Led the program to put the first American in space with the Mercury Redstone Freedom 7 mission when Vanguard failed. So he saved our butt. Yeah. And nice quote here from Program Director Sam Phillips. I do not think the United States would have reached the moon as quickly as it did without von Braun's help. Later, after discussing it, he amended to say he did not believe the United States would have reached the moon at all. So regardless which way you want to think about it, that dude was important, right? Yep. And there he is with his own Time magazine picture, which is how you knew you had arrived on the stage of popularity back then. Some of his favorite projects were how to settle Mars and to construct space stations. So that was something he did even when he was a student in the early 1930s. But there's a bit of a dilemma, obviously. So he grew up in pre-Nazi Germany, dreaming of traveling to the stars, entirely peaceful. He had entirely peaceful intentions. He was being supported by the military because there was no other way around that. But as World War II started, he slid into the Nazi regime. And they embraced him ever more. There's a very curious story. Now, you always see him in a civilian suit, even in the wartime pictures. But Heinrich Himmler awarded him a position within the SS. And in his biography, Wernher von Braun says, I didn't want that, but in those conditions, I couldn't refuse it either. So I'm kind of going to go with that story, but it's still very awkward.
Yeah, well, Wernher von Braun basically said, thank you for this wonderful honor of being an SS major, but I'd like to politely decline. And Himmler said, oh yeah? And stuck him in jail for 2 weeks. And they basically tried to convict him of 62 different crimes that he was not guilty of. And at that point he said, I think I will wear the uniform once, take a picture of me. And that was that.
That is correct. That's correct story from
Very
what I heard.
convincing, a very convincing demonstration by Himmler of what can happen to you. You say no.
Well, he was lucky because you couldn't get rid of Werner von Braun from the space program, and Himmler knew that. Any other person, right, wouldn't have survived to tell the tale.
There were 2 other people arrested at the same time, and you're right, they did not come back.
Mm-hmm. Anyways, let's move on. Now that we spoke about where all the German rocket scientists went, and I'll get back to a conversation that you had there. Where did all those companies go who made rockets and rocket components and jet engines and rocket engines? Where did they go? Talking about the Messerschmitts, Junkers, Dornier, Daimler-Benz. Where'd they go? What are they called today? Airbus. Airbus is the legitimate successor to all European aerospace companies, including the legacy German aerospace companies, right? Now, it's almost completely civilian, which is the great news, and has a great name for civilian aircraft. They make helicopters, and they have a 50% participation in Ariane rockets. So that's the majority ownership right there for the European space program. Generally owned by governments, and so the German and French governments, they have their own 10.8% share. Other companies have lower shares, and the work is religiously divided up by how much you own. This how much business your companies in your country get to do. I think you can get shares too, but the majority is government owned. And just because everybody thinks Airbus is French, right? Yes, Toulouse in France makes a lot of Airbuses. But this is here, for example, Airbus in Hamburg. It's also a very large institute. They put together a lot of airplanes there too. Other places are, for example, we have CASA, the Construcciones Aeronáuticas S.A. in Spain. We have French companies here. There's also Italian, Belgium, and Dutch input as well. So who were some of the other people who got involved? And there's some interesting German connections there too. In this case, the Indian Space Research Organization was set up by Vikram Sabrai. He was actually English educated, and ISRO is now very, very successful. They have launched to Mars. They have launched to the moon, and they do this on a budget which is, what, 10% of NASA or even less, right? So they're quite effective nowadays. This guy here is really interesting, Qian Shuzhen, father of modern Chinese rocketry. He was actually an American-trained engineer, an American citizen. Interesting enough, at World War II end, he went with American experts to pick up von Braun and interviewed him in Germany when Germany collapsed. So had that connection. He studied under Theodor von Karman and von Prandtl, big names in aerodynamics. And he unfortunately fell to politics. So in the 50s, he was accused of being a Chinese spy, being accused of communist, whether rightfully or wrongfully, probably wrongly. Found it very difficult to live in America and went to China, basically forced to going to China. He said, okay, I'll show you guys what I learned, right? He did well. Then we have the Japanese here, Hideo Itokawa. who really set up JAXA. JAXA is also a very competent space agency, right? They're doing very well with certain asteroid missions and moon missions. And there's a little story there. We know that several submarines were sent during World War II with V2 technology to Japan. That was actually a thing. So they went 16,000 sea miles from Germany to Japan and from Japan to Germany. Some of these submarines were sunk, others came through. So we know, for example, they had a complete jet engine from the Germans. They had a complete rocket engine, and they had parts of a V2. But when they shipped a complete V2, that U-boat was sunk. Now, did much of that go into the Japanese rocket technology? I don't know. Maybe not so much, but it's an interesting side story.
I had a copy of the piloted V1.
Mm-hmm.
They got the plans from the Germans. The Germans had actually built several of them, and they were extremely noisy, nearly made the pilots deaf, and so they gave it away to the Japanese, and the Japanese actually built a couple of those manned V1s. And there was at the very, very end.
Those were those cherry blossoms.
Yep, the cherry blossoms. At the very, very end of the war, there was a final German submarine, one of those very latest versions, and it was stuffed to the gills with everything. They even took some engineers along, the German engineers, and at the very end of the war, they gave themselves up. Fortunately, when the Germans quit, and they ended up being interned, or they came ashore in New Jersey, I believe it was, Elizabeth, New Jersey, or Portsmouth, Connecticut, one or the other, but it was in all the newspapers at the time.
Right.
Yeah,
So
flash. Including some containers, little square boxes that nobody knew what they were for. There was a list in the newspaper of, parts for advanced V1, parts for advanced V2, and then numerous
right.
small boxes labeled U235. And nobody knows what happened to those boxes.
Well, and this is one thing one has to recognize here. There's never a national program. Things always go beyond countries' borders, right? So let's say von Braun talks to Goddard, how do you make navigational equipment for a rocket? Then you build it in Germany. It gets exported to Japan or landed in New Jersey, right? So there's a constantly back and forth. And that's how you develop things further, is by collaborating. It's nothing else but a form of collaboration.
Also, so very desperate competition. Who can get there first?
Yeah, very much so. Now, I'm going to tell you why I'm even bringing this story, because I'm probably one of the few witnesses that can tell you something about Operation Paperclip, having seen it in action personally. So I know this person, Heinrich Theurer. He was one of the many rocket engineers born in Silesia, now Poland. He was an engineer. He had no Nazi membership whatsoever. The Soviets captured him first. And so he worked for 10 years for the Soviets until 1955, went back to Germany, and then the US authorities said, hey, would you like to come to New York instead? So he signed up for that. He was obviously debriefed because the Americans wanted to know what the Soviets were doing, right? So that was a good catch for them. So he worked for a couple of years in New York, went back to Germany, retired. And I remember him because I personally spoke to him. He was a friend of the family, and he was a very staunch anti-communist. So his 10 years in Russia said, no, we don't want that kind of thing again, right? So that's one of those kind of stories, personal stories, that are possible. I have a story that's even closer. This is my dad. So he was too young to be in any organization in World War II, but Operation Paperclip went until 1959, right? So a very long time. And I got some very interesting stories to tell here. So he had just finished his PhD in 1959 in Vienna after studying also in Göttingen, and was moved to the US. Now, many, many decades later, like 10 years ago, I actually met his professor in Vienna when I was working for an Austrian company. And he said, "My God, you have the same voice, and you must be Wolfgang's son," and all that. And he said, and then he told me a story I never heard from my own father. He says, "Do you know how difficult it was to get him in the United States?" I said, "No." We had to fly into Alaska, which at that time was not a US state, only a territory. Put him in a closed, sealed car driving through Canada, and hush him to the border without papers. I had never heard that. Yep. So later on, obviously, he legalized, right? But for his whole life, he had to register every year as an alien, hostile alien. That was the official term in the US. And he got to fill out a form, which he threw up over, because same questions every year. And one of the questions was, were you a member of the Nazi Party? No, honestly. Next question was, do you intend to assassinate the US president? Well, who the hell would think you would actually answer that question honestly? Right? So anyway, so there was increased pressure, right? And we felt that at home. My dad worked at Wright-Patterson Air Force Base in the Air Force Field Dynamic Laboratory. And we were told, regardless whether we are American citizens or green card aliens, our mail will be opened, our telephone will be surveilled. And we had no rights to complain about that. When my dad passed away, our whole house was ransacked. Mm-hmm. Anything that was remotely connected with work, removed. So there's a shadow organization that I've experienced here in the US, right? That goes beyond sometimes citizens' rights.
So that was like for around the year 2000, I'm guessing, that your father passed away?
No, that was 73.
Oh, I see. 70.
And this picture here is taken from his US passport. So interesting things that happen with these kind of populations and how they're treated is not always simple. Now, as a kid, I couldn't care less, no, right? But it's noteworthy. Now, I did get to know all the people working at the lab at Wright-Patterson Air Force Base. We had a launch pad for a Gemini rocket, by the way, at Wright-Patterson, our own nuclear reactor. So there was a lot of research going on there. And I can confirm until 1974, the whole department was 100% German.
Know that?
Only 1974 did they put in a manager who was a U.S. Air Force officer.
The token Yankee?
The token Yankee. And I know that because on weekends he'd take me to the base and he'd do work and I get to play around with the gyroscopes and all the good stuff, right? And I'd see all the planes hooked up for measurements and so that was all kind of fun, right? So yeah, that happened there. Now one of his other friends there actually got me hooked on astronomy. So a guy I didn't mention here, Mr. Staller, he was actually Baltic German. So officially he was born in the Russian Empire by two German parents. And when he passed away, he bequeathed his telescope to me. So I was probably 9 and that got me started on doing astronomy. So it's a very interesting community. It was a large community back then. And Even got the Outstanding Air Force Unit Award, amongst others. So I have a whole collection of Air Force awards from my dad. Final chapter. This here is third generation Operation Paperclip, my son. And he's working in Colorado Springs for a defense contractor for the U.S. Space Force. So that's my personal story there too. That's why Operation Paperclip and that whole story means something to me.
What's the galley table?
Well, when you build for $25 billion an International Space Station, do not believe it comes complete with furniture.
Oh. Oh.
So there's an organization called Hunch. It's with NASA. And these are high school students who work on projects for NASA. Currently, there are about 1,000 schools in this program. And Cypress Wood and Cy-Fair high schools joined together to build a galley table for the International Space Station. They designed it, they manufactured it, they tested it, and it then was put on this rocket, delivered to the International Space Station. So super wonderful project. And he got a lot of experience out there. So one day he comes home, says, "Dad, I hate Lockheed." So Lockheed was managing the project. "They changed the specifications on me again."
Surprise.
Surprise, right? So, a very interesting story.
Do you remember how?
No, I don't remember how, but it was significant. So the NASA Hunch program is very exciting and helps a lot of high schoolers, catch the bug and decide for an engineering or even a space career. Yeah, that's it. That's my story.
I guess we'll have time to talk. Thank you so much for.
Yeah, absolutely.
I kind of draw you for some things. Did everybody enter their name in the? And that's a good idea too. Also, just want to tell you we'll meet at PJ's after this. Oh, that's not up there. Let me put this. I guess first off, did everybody enter the drawing? Oh, I'll get it. Thank you. Oh, there you go. Oh, I did? Oh, okay. Thank you so much. Oh, wow. Then I'll just add this in.